everyone, so today we're going to talk about graphing rational functions. And a rational function, remember, is just like a fraction. So you have a numerator and a denominator, and those both are going to be polynomials. And then also make sure that your denominator is not zero. So let's look at some key characteristics of rational functions. So one of the things is that you're looking at x-intercepts, right? X-intercepts of rational functions are the real zeros of your numerator. Okay, so whatever you have an expression in your numerator, you're going to go ahead and set those equal to 0, and you're going to solve. So x-intercepts, you're looking at the zeros of your numerator. When you are trying to find the y-intercept, you are looking at the point where the graph is going to cross the y-axis. So just to know that that is where your x is going to be 0. So y-intercepts is whenever your graph crosses your y-axis. The next thing is finding vertical asymptotes. Now, vertical asymptotes are the real zeros of your denominator. So whatever you have in the denominator of your fraction, sometimes you might have to factor that, so just keep those things in mind as well. Those are your infinite discontinuities. Now, for us to find the horizontal asymptotes, what you're going to do is you're going to look at the degrees. So you're looking at the exponents here. Now, if the degree of your numerator is less than the degree of your denominator, your horizontal asymptote is going to be at y is equal to 0. Okay, so now if the degree of your numerator is actually equal to the degree of your denominator, your horizontal asymptote is at y equals, and then you're looking at the lead coefficients, the lead coefficient of your numerator over the lead coefficient of your denominator. So you just go ahead and divide those. So it could be like 1 over 1 is your horizontal asymptote at y is equal to 1. If you have 4 over 2, lead coefficients, you have y is equal to 2 as a horizontal asymptote. Now, if the degree of your numerator is larger than the degree of your denominator, there is no horizontal asymptote. So one thing that you can do to help you to remember your degrees is that if your degrees are bottom heavy, so they are larger in the denominator, you're at the bottom, right? So you're at 0, you're kind of starting off at 0. If they are the same, so we like to call that even Stevens, right? So they are the same degree, you're dividing your lead coefficients. If your degree is larger on the numerator, we'll call that top heavy, it's larger in the numerator, then think about like once you reach the top, there's nowhere else for you to go, so there's no horizontal asymptote. Okay, so if you think about slant asymptotes, we're going to still think about degrees, but we're looking at specifically if the degree of your numerator is exactly 1 greater than the degree of your denominator. So if that's exactly 1 greater, you're going to use either long division or synthetic division. So you can find the equation of your slant asymptote. And what it's going to be is just going to be y equals and whatever your quotient is. And you are not going to include the remainder. So no remainder, just y equals and then your quotient. You can also have something called a hole, that's your removable discontinuity, and that occurs when your numerator and your denominator have a common factor. So again, it is also helpful for you to make sure you factor everything first. Now with your domain, again, that kind of goes based off of your vertical asymptote as well as your hole. Those things are used together to think about what your domain is. Domain is all real numbers except for the values that make your denominator 0, which are your vertical asymptotes. And then if you happen to have a hole, you have to consider that too and not include that number in your domain. And then when you when we define the range, you just always look at your graph, right? Look at how you've sketched or look at how you would graph it in the calculator. And then you can determine your range that way. Okay, so here's the first thing. We want to find our x-intercept. What we're going to do is we're going to go ahead and set our numerator equal to 0. So that's 2x minus 1 equals 0. You're going to add 1 to both sides. And then x is equal to 1/2. So my x-intercept is at 1/2. My y-intercept is where my x is 0. So if I look at my function here, if I have 0 in for x, I'm going to get negative 1 over negative 6, which is just a positive 1/6. So we're going to go ahead and graph that. Your vertical asymptotes are where your denominator equals 0. So you will actually need to factor that. So what we're going to do is we're going to factor. You're going to get x minus 3 and then x plus 2. So if I set those both equal to 0, I get 3 and negative 2. So we're going to go ahead and draw that imaginary sort of dotted line here to indicate where my asymptotes are. My horizontal asymptote, I'm looking at my degrees. So the degree of my numerator is at 1, and the degree of the denominator is at 2. So what happens is that it's bottom heavy. So it's larger on the bottom than it is on the top. So when you reach the bottom, there is at 0. So y is equal to 0. You're going to look at your slant asymptote, and you're going to see, all right, is the degree in the numerator 1 greater than the denominator? No, that's not true. So you're going to write none. You're going to look at the coordinates of finding the whole. So the whole is, again, where we're going to look to see if we have any common factors in the numerator and denominator, which we do not have, so there's no whole there, so we're good there. Okay. And then if we would graph this, right, you can kind of see the sketch of where the branches of your graph is going to look like. So we're going to have our horizontal asymptote also. Here we go. This one branch is going to be approaching our middle section is going to go through those 2 points, go through, and then in the bottom left, again, go ahead and sketch that curve there. All right, so remember your domain. You got to consider your vertical asymptotes as well as your hole, which we don't have any holes, so we're just going to look at the vertical asymptotes. So I'm looking from the left to right for domain. So what I would do is I would start at negative infinity, and I would go all the way to negative 2. I get kind of stopped by my asymptote there, so nothing past negative 2, not inclusive. I'm going from negative 2 to 3, get stopped by that asymptote, and then 3 to infinity. And then when you look at end behavior, again, you can look at your graph. You can also consider where your horizontal asymptote is, right? What is that value that your function is approaching on either side of your graph as x approaches negative infinity and as x approaches positive infinity. So as x approaches negative infinity, our function approaches the value of 0. And then as x approaches positive infinity, our function approaches 0 as well. The first thing we're going to look at is my x-intercept. So I'm going to take my numerator, set it equal to 0. You're going to get x cubed equals 1. Take the cube root of it, so x equals 1. My y-intercept, if I plug 0 in for these x's, I'm going to get negative 1/5. My vertical asymptote, again, if I try to factor my denominator, it's actually not factorable. You could also check for the discriminant and see, is this actually factorable or not? You would get actually a negative number, so there's no real zeros. So there's no vertical asymptotes actually in this one. So not factorable, wouldn't be able to solve, there's no real zeros. All right, horizontal asymptote, I look at a 3 and a 2, so it is top heavy. So there is none, right? When you reach the top, there's nowhere else for you to go. So there's no horizontal asymptote. So now if I look at slant asymptote, I have a degree of 3 and a degree of 2. So numerator is exactly 1 greater than the denominator. So I am going to do either long division or synthetic division. If you look at your divisor, it's actually not a linear factor. So what I will need to do is I will need to go ahead and do long division. So now our divisor is x squared plus 3x plus 5. And then I have x to the third. I'm missing an x squared and an x term. So I'm going to just put zeros in those spots because we will need those. All right, so I got my first term is x to the third divided by x squared. So that is just x. Now I'm going to multiply. So divide, multiply, and then subtract. I get x to the third power. I get plus 3x squared. And then I get 5x. And then if I subtract this quantity, my first term should cancel. I get minus a negative 3x squared minus a 5x. I'm going to drop this 1. And then I'm going to do negative 3x squared divided by x squared. That gets me a minus 3. You can actually stop here because, again, I'm not concerned about my remainder. I'm concerned about whether or not I can get my quotient. So my slant asymptote is y equals, and then my quotient, which is x minus 3. So if I look at x minus 3, again, that's just a line, right? So I have a dotted imaginary line here. Okay, at x minus 3. I'm going to look and see if I have any holes, and in this case I do not because I do not have any common factors. So there's none. Okay. And then if you actually were to graph this, you're going to see we can kind of go alongside our slant asymptote, come up a little bit like a little hill, and then follow along our slant asymptote. Again, when you look at your domain, looking from the left to the right, considering my vertical asymptotes as well as my hole. So I have negative infinity to positive infinity. And then my end behavior is actually, again, looking at my graph or looking also at my horizontal asymptote, which I don't have any. But what's going on? I've got my x approaching negative infinity, and my function is pointing down towards negative infinity. And as x approaches positive infinity, my f of x, or my y values, are approaching positive infinity. Okay, in this question, you've got some trinomials here. Would recommend that you factor first, so it will be easier for you to find your vertical asymptotes if you have any holes, things like that. So my numerator, when I factor this, will be x minus 3 and x minus 5. And the denominator is also factorable, so x minus 3, x minus 1. It's important to note that you do have a common factor, right, that x minus 3. So those are going to cancel out. And now when I look at my x-intercept, you get x minus 5. The 0 of that is at 5. When I look at my y-intercept, plugging in 0 for x's, which simplifies to a positive 5. Here we have our vertical asymptote, which is our denominator, which I have just one of them, which is x equals 1. Horizontal asymptote, you are looking at the degrees, so you have degrees that are the same. Okay, so they're even, right? So they're even. So if they are even, I'm looking at the lead coefficient. So what are my lead coefficients here? 1 over 1. So y is equal to 1. So here's my other asymptote here. Y is equal to 1. My slant asymptote, my degrees are the same, so I don't have a slant asymptote, so we're going to write none. You actually do have a hole in this, and it's because you have that common factor. So that x value is 3. And then in order to find the y coordinate of that hole, what you're going to do is you're going to take that 3, you're going to plug it in. You're going to plug it into wherever you have an x. So you have 3 minus 5 over 3 minus 1, which gets you negative 2 over 2, which simplifies to negative 1. So at 3, negative 1, you have a hole. We have an open circle there. All right, so now what we can do is we can say, all right, well, I know if I graph this, I can see where my branches are. I've got a little curve here. In the lower right, I have a curve. I pass through that x-intercept, but the hole, I'm going to sort of jump over it there. So when I look at domain, again, consider your vertical asymptote, and now consider that you have a hole here. So look and see what's happening. As I'm going left to right, I'm going negative infinity for my domain all the way to 1. I have a u. I'm going 1 to 3. 1 to 3 because at 3 you have that hole. So you do need to consider that you have a hole there. So you can't just say you have 1 to infinity because you cannot include that 3. And then as you continue on, you have 3 comma infinity. So that is your domain. We look at end behavior, we're considering that we do have a horizontal asymptote. So when I look at my graph, I'm looking at what's the value that my function is approaching. So my f of x is approaching from the left, it's approaching 1, and from the right, it is approaching 1 as well. Don't forget to like and subscribe if you found this video helpful so you can get more notifications on pre-calc videos. Have a great day and see you next time.